light-based model. And for those of you who have been following the cosmology of light channel, you'll see that this is a familiar model, but I'm going to break it up. And essentially, the way to think about it is that it's a multi-layered symmetry-based model of light. And the starting point is this top row in this matrix, which is denoted by C with the subscript infinity, which really implies that light in its native state is traveling infinitely fast. So let's just think about that for a minute. If light were to travel infinitely fast, and if we assume that we have some kind of volume, then if we have a light source at the center, essentially light's going to be present in that whole volume instantaneously, so it's going to have a property of presence. Now, if something not of the nature of light were to arise, then light would subsume or overpower it, and therefore there's also this property of power. Since light exists in this entire volume, anything that appears or disappears in its fabric is going to be instantaneously recorded, and so light has a knowledge, and so there's a property of knowledge that also arises. And since everything exists in this fabric of light, there's a harmony that also exists, and therefore there's a property of harmony. So just through this simple thought experiment, we've derived, in a sense, these four properties of this conceptual space where light travels infinitely fast. And so that's the starting point of this light matrix. Now, as we go down to the second row in this matrix, this is actually a quantization function. And what it's saying is that the reality that emerges when light projects itself at speed k, which is denoted by this subscript k in the third row here, is some function of the reality that already exists when light travels infinitely fast. And this quantization function, it makes more material these subtle aspects of presence, power, knowledge, and harmony. And the way that it does that is that it differentiates each of these four properties into large sets where, for example, if we consider knowledge or power, each of these elements get differentiated into sets of almost, practically speaking, infinite elements that have to do, for example, with knowledge or power. So there's a materialization, an increasing materialization of these subtle concepts. And that really is what this row over here denotes. So what you see is these four sets: a set of presence, a set of power, a set of knowledge, and a set of harmony. And then similarly, there's another quantization function that occurs that makes these properties of this reality in light even more material. So what we have here in this third layer, denoted by the subscript n over here, so when light is traveling at some speed n that is higher than our known speed of 186,000 miles per second, but quite a bit lower than infinity, then essentially through this quantization, there's a further materialization of the infinite information that exists in light. And the way that this quantization or this materialization is envisioned to occur is that these four sets that we have, the set of presence, set of powers, set of knowledge, and set of harmony, since they have practically infinite elements in them, in this layer, the quantization is such that there is, you can say, an infinite number of permutations and combinations to create unique elements. And these unique elements are really summarized by this formula over here, where Cn is a function of the elements of essentially the four sets. So you could have infinite number of subtle seeds that are being created. And then the final quantization that is depicted in this matrix is one that we're more familiar with. And that's when light propagates itself at 186,000 miles per second. And that creates the basis of this immense diverse material field that we exist in. But you can see that really the source or the root of that infinite diversity are these infinite number of subtle seeds that exist in some antecedent layer of light. And so before we move forward, there are a couple of things to point out here. One is that I refer to this as a symmetry-based model of light, and it's symmetrical essentially because as we look at each of these subsequent layers, they are all hinged around the four properties of light. So the symmetry is that these four properties exist, but they show themselves in different ways depending on what the speed of light is. So the variable here is speed of light. And as light projects itself at slower speed, we see different aspects of the same four things shown to us in a different way, and therefore it's symmetrical. And I'll make one more point before I hand this to Lalita or for any conversation that we want to have. And that is also that there's a prediction that essentially is coming out of this model. And that prediction is that if we want any kind of robust, complete, sophisticated computation to occur, then it has to be a function of all four of these properties: presence, power, knowledge, and harmony. So any kind of robust quantum computational model that emerges, this is predicting that all four of these aspects would have to be present and combined in such a way that in that computational model, these four things that have to do with presence, power, knowledge, and harmony would somehow work together. So let me just pause there. And Lalita, I don't know if you have any comments or anything that you'd like to add at this point.
Sure, Praveen. Thank you. So basically, we are saying that light emerges into other matter forms, like, what we see as matter in reality is essentially light propagating itself in these different speed levels and giving rise to all reality that we see. Is that true?
Yes, exactly. Yes, that's true. Yes, and I think that one way in which that practically may happen is that if we think about Planck's constant, then I would, which is perhaps one of the smallest measurable quantities, and it's essentially an integral part of how a quanta or a photon shows itself, because there's a correlation with this Planck's constant. But if we probe a little further and ask what really is Planck's constant, in this multi-layered light point of view, I would propose there's an inverse proportionality between the speed of light and, in fact, h, which we know as Planck's constant. And so as c becomes more finite, so at 186,000 miles per second, then h becomes a larger value, because if you have c at infinity, then h is 0, being inversely proportional. But when you lower c, then h becomes bigger. And so it reaches a threshold level where matter can form.
Understood. That makes sense, Pravi. And another way to say it is by considering the wave-particle duality of light, right? How light shows itself as a wave at some time, and it also behaves as it's a bunch of particles at other times. So can we talk a little bit about that, Pravi?
Yes, absolutely. And I think that's also a really good point you bring up, Lalita, because we, in our current interpretation and understanding of quantum phenomena, we certainly have tapped into this aspect that there's something that's very full that's behind the particle aspect that shows up, and we refer to that as a wave. What this model is even proposing or predicting is that the wave itself is a materialization of something that's even more subtle or even larger. So in fact, if we look at the fullness of this model, we might be able to say that there is a block field wave particle quadrality, not just a duality, but there's potentially a quadrality that exists, that of which the wave particle duality is so far the measurable part that we've been able to interpret when we try and understand or penetrate into quantum phenomena.
Absolutely. Thank you.
Should I move forward then?
Yes, yes. So I'll be dealing with the next part of the presentation now. We have discussed so far about the 4 properties of light and the light-based model, where it exhibits properties such as the presence, power, harmony, and knowledge. Now we will try to apply that model to quantum computing to see if that really holds good, and if we can probably relate it to some examples and understand if this model still holds good. So first property we are going to talk about is the quantum superposition. And a superposition basically means that being in multiple states or existing in multiple places or states at the same time. In classical computing, we are not familiar with this concept. It is all a binary system. We have either a 0 or 1, which we call as bits, and that is the basis of all quantum computing. Classical computing. But in quantum computing, we have something called as qubit, which means it can be 0 or 1 or both at the same time, basically in a superposition of states. So that is, the property of presence that we are relating to, and we can discuss this in detail by taking the famous example or the experiment of the double slit, famous Young's double slit experiment, where we assume a single photon light source and we try to pass that single photon through 2 slits. And what we see is that this one photon goes through both the slits and records on the screen as a wave. And when we measure it, it will record as a particle. So we are trying to showcase that light exists in 2 places at the same time, even though we expect it to behave as one. So it is in a kind of superposition and it is proven and recorded. That is the multi-presence or the omnipresence property of light that we are seeing here, which is the core pillar of quantum computing. Quantum computing basically gets its strength or the extraordinary computational ability using superposition and some other properties which we are going to discuss in the further slides. So this is one phenomena which we can relate to this multi-layered model of light, which proves the presence property. So the next property we are going to see is the quantum entanglement. And this is also one of the core pillars which gives quantum computing its true power, because when we deal with any subatomic particles like photons or protons or electrons, if we take any subatomic particles like this and we prepare them in a certain way and then separate those particles by vast distances, like if we take the other particle to the other side of the universe, even then when we perform a measurement on those particles, without any communication, that at this point of time we are going to make this measurement, even if we don't share that knowledge with the other party, the results of those measurements are always 100% correlated. This kind of shows the power of knowledge sharing. I mean, the particles kind of communicate with each other, share the knowledge with each other's outcomes of measurement, and they kind of correlate 100% of the time. So this shows the knowledge aspect of light, and that's what we discussed as the second, symmetry in the fourfold model of light. So quantum entanglement is also a core pillar, like we discussed, which is giving quantum computing its power, because we don't have to make measurements on multiple particles at the same time. We can make a measurement on one, and then we would know what the outcome of the other entangled particle is, and that gives a good computational ability to the computers. So that's the second property. And the third property is quantum tunneling. So we discussed about the power property of light, which basically has the ability to avoid all other forms and manifest itself into other layers of light. So what this tunneling is showing is we have an experiment where we take a particle in a box and we expect that particle to remain in that box and not outside the box when the walls are not infinity. The thickness of the walls is not infinity. But what we see is sometimes when we make the measurement, there is a non-zero probability of finding that particle outside the box, which means light can be present outside the box even when we don't expect it to. It has the power to penetrate and be present at other places, and it has the power to tunnel through these walls and end up being on the other side. So that is the power property of light, and this is a core aspect of quantum computing, which will also connect with the other two phenomena, and it gives the ability of higher computational power. And then last property that we are going to talk about is the quantum annealing, where we talk about harmony in the sense that according to the second law of thermodynamics, we know that everything in the universe tries to be at a minimum energy state, which means, for example, if you take a cup of coffee, hot coffee, and keep it there, it will eventually become cool and it adjusts itself with the room temperature. So it kind of attains that equilibrium and tries to get into a state of harmony to adjust itself to the surroundings. Same is true with quantum computing, because we have a property called quantum annealing, where we notice that if we assign some weights to the different states of a problem, we assume that different variables are different states, and we assign weights to those states. Universe or nature itself will provide the minimum energy state, and we don't have to do all those computations to find out what is the best possible solution to a given problem. Nature will find it for us, and it will give us the best, most efficient solution to a problem, and that is through quantum annealing. It basically attains a level of harmony, and that is what we are relating to the harmony property of light. This completes the 4 layers, and we can see different examples of how these 4 layers work with quantum computing.
Thanks, Lalita. And what also I'll say that so I think that the jury is still out, in the sense of our current understanding of these phenomena, whether it's superposition or entanglement or tunneling or annealing, is, I think, just at the surface level. Or I think there's a lot more that potentially, we need to penetrate into and understand, how really what's the dynamics of superposition occurring? We have some formula at the moment that will give us a sense for how to compute outcomes and things, but really what's the mechanism, what's happening, behind the scenes. And I think that looking at things from this multi-layered symmetry-based model, might provide some additional insight into how to think about these different phenomena. So just one quick example, if we think about superposition, and we have, say, 4 quantized layers of light that have their own logic and how they show up, and there's a certain kind of quantization that is suggesting that it's now a whole, and therefore it shows up at a lower speed. But the point being is that any particle that shows up at the material layer that we understand it has counterparts or these subtle kind of information that exists at multiple layers of light, not just in a wave aspect, but if we want to get a little more rigorous about thinking from this point of view of this model, then superposition then becomes almost like 4 different functions that express themselves materially in an arbitration that's taking place. So the point being is that we can consider each of these different phenomena with a little more kind of detail or a little more rigor if there was something like this symmetry-based model of light that we use as a basis. So
Yeah, definitely.
and would you like to just summarize and conclude there, Lalita?
Sure. So what we are saying here is we have this fourfold model, like Praveer explained, all these different properties of presence, knowledge, harmony, or power. Yeah. So all these four properties, we are trying to relate those with the existing proven phenomena of quantum computing, and they are exactly matching with these four properties, where we saw the superposition in a practical experiment called double slit, and it is exactly what the all presence property is saying. And we are talking about the knowledge property, where the particles or light should know what is happening throughout the universe, and that is proven through entanglement, and the particles are really communicating and correlating with each other when we make a measurement. And the third property, tunneling, it should exhibit the power property. We don't expect it to show up on the other side of the box or the barrier, but it does, and that is the power that light exhibits, and it correlates perfectly with quantum tunneling. And the harmony property again so symmetrical to the quantum annealing in the quantum phenomena, because it also shows how the more dynamically we have seen in the quantum classical environment, the same exists in quantum world, and all these nature itself provides that harmony and the most effective solution at all times, which relates to the harmony property. So yeah, so that's the summary and the conclusion we are trying to arrive at, where we take this four-layered approach and apply it to quantum computing. It fits exactly within the puzzle, and we then propose that this is how we should approach to the next problems, not just as wave particle duality, but the quadrality, like Praveer mentioned. We should also take into account this knowledge, this power property, this harmony aspect, along with the superposition and presence. So that will give us the complete picture, is our proposition in this paper.
Thank you, Lalita.